So hello everyone, and welcome to this Royal Society of Chemistry Higher Education Teaching Award keynote lecture. My name is Dr. Glenn Hurst. I am an Associate Professor in Chemistry Education at the Green Chemistry Centre of Excellence at the University of York in the UK. And today I'm going to be talking to you about green chemistry education for a sustainable future. My aims associated with this talk are to effectively take you on a journey to appreciate the theoretical framework that underpins all of my work within green chemistry education and show some indicative examples from when I very first started out to the present day. A useful overarching framework that I like to use is the United Nations Sustainable Development Goals. This is a worldwide agenda where there are 17 interconnected and interrelated objectives where by 2030 seek to address the big global challenges such as relating to poverty, quality education, environmental degradation, peace and justice, access to clean drinking water, etc., etc. And in order to solve these big, grand challenges, it's going to require teams that are working together across disciplines in an interdisciplinary fashion, and also not a reductionist approach, but one that is more holistic, that considers dynamic, changing components, effectively consideration of entire systems. And so, in order to tackle these big, grand challenges, I like to imagine what could the future look like? What do we want it to look like in 10, 20, 50 years' time? And I would argue that, well, the future is going to look like what we design it to look like at this very time. And then those in 30, 40, 50 years will comment on to what extent our design and implementation has been successful. So, taking an example from my recent golf competition at Seaton Carew Golf Club there, this was my shot in on a par 4, and I wanted to hit the green. Now, there are numerous options and considerations that I have to make here. Okay? I have to think about multiple components that contribute towards the desired output, which is to get the ball as close to the pin as possible. I have to consider the quality of my lie. I have to consider which club that I will use and what sort of swing I will implement. How quick or slow, how steep or shallow. I'll have to consider wind direction, left to right, right to left. I have to consider elevation. I have to consider whether I'm going to aim for the pin, where, as you can see, there is a rather deep bunker in front of it, or still hit the green, but perhaps land the ball to the left-hand side. There's a lot of complex decision-making within this shot here. Actually, if you're interested, I took a rather aggressive line and unfortunately didn't quite pull it off and ended up in this bunker here. Fortunately, I was able to play a bunker shot and get down a decent score. These are the sorts of complex considerations that feed into my own pedagogy. And the discipline that I'm interested most in order to perturb our current system and design for a future that I would like is using green chemistry. Green chemistry can be defined as the design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. And I would argue that the most important word in that definition is the word design. Design is a statement of human intention. And as mentioned, it is design that will be absolutely critical to help us change our current unsustainable trajectory as a planet. So where does our work as educators come in? How can we equip the scientists, engineers, and policymakers of tomorrow with the holistic, systems-based skills in the context, in my case, of green and sustainable chemistry education? Well, the key goal into achieving that, thinking about the United Nations Sustainable Development Goals, is UN SDG Goal 4, quality education to ensure inclusive and equitable education and to promote lifelong learning opportunities for all. And the pedagogic framework associated with achieving that, according to our approach, is systems thinking. Indeed, systems thinking uses cognitive frameworks, strategies, and tools to help learners see the relationships and the interconnections between various subject matter. It allows learners to think dynamically and think about how the system may evolve over time. And it allows learners to think about, upon a perturbation, a change in input, a change in conditions, how outputs or indeed systems level phenomena may emerge from various components, various subsystems interacting. As you may predict, this is quite a high order skill. And effectively, through getting students to effectively practice systems thinking, we're hopefully going to assist them in transitioning from a fragmented and reductionist approach to one that is more integrated and lateral. And it happens that green chemistry is very well suited to a systems thinking approach. The 12 principles, life cycle assessment, moving from a linear to a circular economy, and process considerations all depend on the reliance of reactions and processes on each other with global and local systems. And I would say that green chemists have been using systems thinking since the very outset. So what is our approach? You can read more in this article here, but effectively my work to date has been utilizing systems thinking as the underpinning framework to make a difference and develop in various areas of the curriculum, from laboratory experiments to using technology and games effectively, to looking at course level recommendations and designing courses and programs embedding systems thinking in the light of green and sustainable chemistry there. And so what I thought would be useful, especially for the newer members of our chemistry education community, is to articulate how I got started. And I'm referring to my days as an undergraduate student when articulating this. So this was circa, I think it was a summer internship that I completed in around 2010. And this was working with Professor Christoph Salzman, and we wanted to develop a rheology experiment to allow students to make a link to the lecture material, which is really quite complex in this area of material science, and physically manipulating and creating gels and the associated analytical skills in order to monitor their behavior, gelation, whether it's shear thinning or shear thickening, any sort of time-dependent behavior, etc., etc. And through this, I just want to articulate from a student perspective my takeaways. Well, it was a brilliant experience for me ahead of my undergraduate MChem research project. It was one of the first opportunities that I had to work as part of a team in a team-based environment within chemistry. I thought it was great to have a positive impact on the learning experience of my colleagues in lower years by implementing a new laboratory experiment. At a young age, I knew that I loved teaching, and certainly designing and executing this resource that would hopefully make a difference fueled my own passion within the learning and teaching space. It also instigated me to explore, specifically explore continuing professional development opportunities, and it was fantastic for me to attend my very first Variety in Chemistry Education and Physics Higher Education conference back in 2014. I didn't present anything, but it was fantastic just to listen and to learn and to meet new colleagues. It was also great certainly from an employability perspective, but also for a prestige perspective to get a publication out of it in the Journal of Chemical Education. And I believe it did really enhance my employability prospects and actually provide me with something distinctive ahead of applying for my teaching focused role at the University of York there. And so the next stages, or critical stages, I believe, within my development within this area was to learn from practice around the world. What's going on in the chemistry education space in different countries, specifically in less economically developed parts of the world. And I was lucky enough to go to Belém in Brazil back in around 2018. And this is known as the gateway to the Amazon rainforest. And you can see the conditions of very typical schools and what a typical classroom looks like. I mean, this was probably the best school that we actually went to. And you will see that one of your questions may be, well, where is the lab? There is no lab. This is what was available within this school. The actual lab was, I guess, the Amazon rainforest and outside. As you can see, very cramped conditions, no real space between the instructor and the rest of the class there. And you can see two students here, Federico here, I'm not sure the name of this lad, actually building something. Can anyone guess what this is? It's actually a fume hood. And seeing and learning about this environment that school children and even university students actually have in this area of Brazil and indeed in other places that I have visited was a key driving force for me to try to make a difference within my area of learning and teaching using a systems thinking approach within green chemistry education. So I had that in the back of my mind, and I wanted to pay back the opportunities that I had as an undergraduate student and to achieve innovation and making a difference in this area. I wanted to work very closely with students as partners, both as part of their degree program and as part of internships, be it undergraduate project research students or postgraduate project research students. And the first port of call for me was to develop transferable laboratory experiments that could be implemented all over the globe. And I wanted to particularly focus on Brazil, given the collaboration that we have there and the strong links. And you can see these are students in York initially trialing this experiment where they were valorizing waste orange peel. Waste orange peel is something that is a big issue in Brazil as the biggest exporter of oranges. And unfortunately, a lot of it goes to landfill, but we can extract valuable chemicals from that. And that's exactly what these students were doing to actually make usable products, in this case, marmalades, where students, as you can see through this publication, examined the rheology of it. And also through this publication, you can see that this experiment was created with students as partners. Lucy, Helen, and Robert are all students that were working with us. And this is just one example of other transferable experiments and demonstrations that we have made and implemented with our friends overseas. And so, following on from gaining confidence in developing laboratory experiments and with new and continued collaborations across the globe, really, I felt as though I had the confidence to move more into uncharted waters, but again, work very closely with students as partners. So yes, continuing our work in green and sustainable labs, but moving to other areas, such as using technology, specifically social media, in new ways, to develop games for learning within green and sustainable chemistry. Some examples here. And as I've mentioned, working very closely with students as partners to actually try to make a difference in each of these areas, embracing systems thinking as a framework to actually achieving that. And then from doing that, moving on to international projects that are going to make, hopefully, global systemic change. So these are both ongoing projects. One is the Green Chemistry Teaching and Learning Community. This was a $250,000 project via the Argosy Foundation through Beyond Benign and the American Chemical Society Green Chemistry Institute, where the goal is to develop, distribute, and share high-quality green chemistry education resources with educators, students, and stakeholders, to include industrialists, for example, to shift from a global community of practice to one of transformation. And I am co-leading the educational resources subgroup to actually develop this exciting new platform that we will see come to fruition in the very near future. A related project is working with the United Nations, specifically through the Environment Programme, to develop a specialized manual on global green and sustainable chemistry education. So watch out, because this is going to be out soon for your perusal. So why? What motivates me to actually do this? Effectively, to perturb the system, to be able to move away from our current unsustainable trajectory depicted via this rather dystopic image here to this, one of a utopic image from my imagination that I would like us to get to through quality education via a systems thinking approach of the next generation of scientists, engineers, and policymakers. And with that, thank you ever so much for the invitation and for your kind attention. Thank you.